right. All right, theoretically, we should be live. Hey, everyone, how's it going? Welcome back. Sorry about last night. We had about 60 millimeters of rain yesterday fall, which I think was a record for that day, this time of the year. And the rain was hitting the trailer so hard that it was just roaring. And so Carla and I were like having to yell at each other to actually be able to talk to each other. And I could just tell, like, the sound was just going to be overwhelming. Anything I tried to record at that point was just going to be ridiculous. So I didn't bother. That said, it's raining right now, but it's not very strong, so it should be all right. So apparently, as the weather changes, the mice have been getting a little more aggressive, and we trapped 6 mice in the last day, and moved them. So took them for a little drive about 2 kilometers away, over a couple of rivers, and released them there. So, but I think we've gotten 10, 12 mice make their way into the trailer, and like we've tried, like, crawling around on the underside of the trailer with spray foam, trying to find every single little tiny hole that a mouse could get into, and somehow they're still finding their way in. But we've got a pretty good system at this point. We've got like 2 places where they really find their way into the trailer, and there's a good trap right there that they just, like a live trap, and they just keep going into it. And so I'll find some hungry mouse inside the live trap chewing on a peanut, waiting to be relocated. Yeah, it's crazy. The studio can't come soon enough. We did a whole new road in the last week, so we've got a like a proper rock road. It's made of like shattered rock. I don't even know what the stuff is. And it's like concrete, but it's cheaper. And so we've got that now, sort of making its way up to the build site, because there's been so much rain, it's just like a muddy mess. So yeah, it's been good. Get a couple of cats. Yeah, cats are. I mean, the problem with cats is they just kill a lot of birds, and what we don't want we want to keep the birds. We don't want to have the birds eaten. And I used to own a cat, and my cat would just murder birds at a high rate. So, I mean, the new place will be rodent proof. It should be fine, and we'll just take care when we're sort of thinking about our environment. I mean, we live in a forest, so they were here first. It's not shale. It's like hard rock. It's like granite. It's like a hard rock, and they just have a huge place where they're mining it out, and they crunch it up with big rock grinders, and then fill up a truck. And so the pieces are like fist-sized and smaller, and when they lay this stuff down, it all just turns into this sort of interlocks, and the water can pass through it, but it just turns into this really strong bed. Logging roads use this all over here on Vancouver Island. And and we did an inspection for our perimeter drain, so that passed. So that's our second inspection down. Next comes the floor, and then hopefully then we'll put on the walls and the roof, and we'll then have a place we can kind of lock up and keep things dry. So it'd be nice. All right. Okay, so I'll start the recording, and then we will get into the questions. Okay, so as always, I got a couple of prepared questions first, which we'll tackle, and then we'll get into your questions live today. All right. Recording reminder. Yes, I am recording, Chad. It's pretty cool, actually. Chad's got this recording reminder button on the interface that I use, and I can't access the rest of the tools until I've clicked that button, confirmed that I'm recording. So we'll try to think through every single step of this process. All right. Hey everyone, Welcome to the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I'll answer them here. Now, once again, I record this show live normally every Monday at 5 p.m. We had to record a day late because of weather. That sounds weird. But if you want to join us live every Monday at 5 p.m. Pacific time on my YouTube channel. All right, let's get into the questions. Matt Lowe, why is iron the largest element produced in a star, and where do all the bigger elements come from? Okay. At the beginning of the universe, all there was hydrogen. And then for the briefest moment, the entire universe was kind of like the core of a star. And so you had nuclear fusion going on. And hydrogen, some of that hydrogen got turned into helium. And so now we end up with about 75% hydrogen, 25% helium. And then you got small amounts of other heavier elements. And then the universe expanded to the point that the hydrogen was so far apart that it was no longer the interior of a star. And then the material had to come together through gravity to form stars. And then inside those stars like, say, the sun, you've got hydrogen turning into helium inside those stars. And as the star runs out of hydrogen in its core, it'll shift to higher and higher elements on the periodic table. Maybe it'll start creating carbon or silicon. And for the most massive stars, they just walk up the periodic table of elements until they get to iron. And the thing with fusion is that when you combine 4 hydrogen atoms, and through this process you get turns into helium, there's like a bunch of steps. So it produces gamma radiation. So it is an exothermic reaction. And all of them, like when you fuse helium, it's an exothermic reaction. When you fuse carbon, it releases energy. And all the time, it's actually keeping the star inflated. The energy is pushing out, and the gravity of the star is pulling in, and you get this balance, and so you get the star. And over time, as the star goes up and up and up this periodic table of elements, it reaches iron. And the difference with iron with the rest of the elements in the periodic table is that iron is not exothermic. So that when you fuse iron atoms together, you don't get any energy out. And so this energy, this pressure that was pushing outward on the star suddenly goes away. But you still got all that gravity pulling in on the star. So I just explained the story of all of the elements up the periodic table until you get to iron. And then what happens is when the star turns to iron, when the center, it's not the whole star, just the very center, the part that should have been fusing and producing energy and keeping the star inflated, when that turns to iron, there's no longer energy. And so you've got the inward force of gravity, no outward pressure, and the star collapses in on itself. It implodes and turns into a neutron star or a black hole. But as this material is coming down together, it's essentially mashing with all of this pressure. At the end, it's sort of moving about 70% the speed of light. And it's like this force just pushing it to sort of cram all that matter into this tiny space. And that's how you get a black hole. That's how you get a neutron star. And not all the matter goes into the black hole and the neutron star. A lot of it just bounces out. But that pressure fuses these atoms together to make elements that are higher on the periodic table beyond iron. That's where you get your gold from, your silver, your plutonium, and many of the other heavier elements. And so that's one source of those heavier elements. The other source of the heavier elements is when you get those neutron stars, when they collide with each other, they can form large amounts of these heavier elements. Obviously, maybe they form a black hole. We're not entirely sure. Maybe they just, when they collide, they just break each other apart completely. But you get this merging of these elements, and you get this enormous release of the heaviest elements, the gold, platinum, plutonium, etc. And so that's both why iron is the most you can get in a star, and that's where all of the heavier elements in the universe came from. Right. Sam Hill, Fraser, I have a question for you. When I watch close-up videos of rockets blasting off, it looks like ice is falling off it while lifting off. Is that really what it is? And if so, why? Thanks. Yeah, it is ice that's falling off the outside of the rocket. And I think the best example, the classic example that we've all seen, is the launch of the Saturn V rocket as part of the Apollo missions. You got these incredible film footage, close-up shots of the Saturn V taking off, and you can see these chunks of ice falling off the outside of the rocket. So what is this ice? Where did it come from? In rocket fuel, in say the Saturn V, but say the space shuttle is a much better example. You've got a rocket that is, you've got a fuel, a propellant, that is liquid hydrogen and liquid oxygen. And both of those can only be kept liquid at incredibly cold temperatures. So they're under huge pressure, they're very cold temperatures, and they're kept inside the propellant tank of the rocket. And so because they're very cold, and even if they surround them in insulation, that cold temperature is surrounding the tank. And then condensation from the air collects onto the outside of the tank, and because it's so cold, it starts to form ice. And over time, as it takes, they may start fueling the rocket. It has to sit there for hours, perhaps in the moist Florida sun, and collect this ice on the outside. And then when the rocket starts to launch and shake and rattle, then this ice can break off and fall down. So that's why they get it. Right. Bo Danner. Question, Fraser. Launch from Earth. What is the theoretical limit of the speed a vehicle could achieve using any and every gravity assist possible in our solar system? No, do this again. Bo Danner. Question, Fraser. Launch from Earth. What is the theoretical limit of the speed a vehicle could achieve using any and every gravity assist possible in our solar system? One of the big discoveries in space navigation was this idea of the gravitational assist. And we've done many videos in the past, but I'll give you sort of the short version, which is that when you fly your spacecraft towards a planet, say when you're launching from Earth and you're flying towards Jupiter, you fall into, drop my phone, you fall into Jupiter's gravity well as you approach Jupiter, and then you fly out the other side. And so Jupiter accelerates you as you come towards Jupiter, and then Jupiter slows you down as you're getting away. It's imagine you're sort of going down into Jupiter's gravity well and you're going back up. But Jupiter also has an orbital momentum as it's going around the sun. And so when you approach Jupiter with your spacecraft, if you can get very, very close to Jupiter, you actually, with your spacecraft, can kind of slow down Jupiter. Or what's really happening is that Jupiter is pulling the spacecraft up to its orbital velocity, which is slower than the Earth. I know it's kind of complicated, but essentially you are gaining orbital momentum and you are stealing it from Jupiter. And then you do this flyby and you continue on through space. And what you get is a net benefit. You get an increase in your velocity. And then you can do this again. You can do a flyby past Saturn and get another increase of velocity. And in fact, first limit is the escape velocity of the solar system. So, which is, depending on where you are and how fast you're going, depends on whether you measure it from the sun, whether you measure it from the Earth. But say if you're in Earth orbit, and you are attempting to then leave Earth orbit and leave the solar system entirely, it's about 17 kilometers per second. So you've already got 30 kilometers per second of velocity because you're joining the Earth around the sun. You need another, say, 17 kilometers per second. And so if you do a couple of flybys and you end up on a speed that's faster than that escape velocity, well, then you just won't be able to come back into the solar system to fly past another object. So the most sort of like the perfect gravitational assist would be to come as absolutely close to Jupiter as you could, like literally skimming the cloud tops. I mean, really going through the center of the planet would be the best, passing right along its center of mass. But then you could theoretically get about an 80 kilometer per second boost as you fly past Jupiter. And so really you don't need to do a bunch of complicated ones around many. You just need to do one really precise flyby past Jupiter to get the maximum speed possible. And then you're going too fast, couldn't do any more flybys, like unless you lined up. So you did Jupiter, and then you got Saturn, Uranus, and Neptune. and they're all lined up perfectly, then you could probably get even a little bit more of a kick. And then you're out of the solar system and that's it. But it's still like a fraction of the speed of light. It's still going to take you thousands of years, even with that, to get to Alpha Centauri. So it's not enough of an assist. Okay, those were the prepared questions. So now let's do the do your questions. Sorry, I'm just like, here's the rain. Yeah. All right. Pontus Ignelli. No, this is again. Pontus Ignell. Would it be possible to use a black hole or such to pull something out from within the event horizon of another black hole? No. Even a black hole cannot pull something out of another black hole. The whole point is that the event horizon of a black hole is the point at which you would have to be moving faster than the speed of light to be able to escape. And since nothing can move faster than the speed of light, nothing can pull you out of the black hole. So once you cross the event horizon of a black hole, you are inside that black hole's event horizon and you're never coming out. Even if another black hole comes really close, even if a supermassive black hole comes really close, even it can't pull you back out of the black hole. You're gone for good. UK Manlows goes, what are the chances of aliens having compatible body parts for romance option? Very low. Vanishingly low. When you, like, this is not Star Trek. Trey Harmon, in recognition of Game 1 of the Baseball World Series, would be willing to say a few words of sports commentary as you do sometimes? What? Sports ball? I didn't even know that the World Series was happening right now. There you go. Okay. Arjun, where do you stand on the teleportation debate? Is it a life murder machine or just fancy transport? So Sabina Hassenfelder just did a video on that. I'm assuming that's why you're bringing it up. We actually did a video a couple of years ago on the channel about that. And most people feel like it's a murder box. It's a suicide booth when you step into the transporter. It kills you and then creates a copy of you somewhere else. And that copy thinks they just were teleported, but you were killed and that copy was created out of nothingness. I mean, the question really is, do you have a continuation of your consciousness from when you step into the transporter to when you arrive at the other destination? The person who arrives will think they did, but the person who got into the booth won't think they did. So that's, but I mean, Sabina is a physicist, so she knows way better than I do. And she doesn't know the answer. So I'm going to just assume she's right. And the answer is more complicated than we think. Because I find it usually is. Like, whenever you think you know something, it turns out the answer is more complicated than you thought. Ooh, that's a good question. Scurvy Sam, what is the deadliest thing the farthest away from the Earth that can hurt us? The universe is really just trying to kill us all the time. And so it has no shortage of ways to wipe us off the Earth. But I would say the thing that is most likely to harm us, that is also like the farthest away, is going to be a gamma ray burst. And astronomers are fairly sure at this point that a gamma ray burst is a kind of really powerful star that dies and detonates as a supernova, but it's got this incredibly tangled up magnetic field. And so when all of the energy detonates out of the star, it's channeled along these magnetic field lines. And if you happen to have one of these magnetic field lines pointing directly at Earth, then it's like a death beam that can shoot for tens of thousands of light years and cause damage. In fact, if a gamma ray burst went off and was pointed at us, pretty much anywhere across the Milky Way, it would be able to strip the atmosphere off of the Earth, which is kind of scary. Now, the gamma ray bursts that we see are in other galaxies. We see them very far away, tens of millions of light years away. But to have one, or even like billions of light years away. But if we have one go off in the Milky Way and it happened to be pointed at us, it would be a very bad day. And so I think that would be the worst. But astronomers have looked, they haven't been able to find a single star that has the potential to become a gamma ray burst that is directed towards us. So we're safe. Don't worry about it. But still, that would be the thing. Arjone, if Blue Origin builds Orbital Reef, would NASA be allowed to rent space? Yeah, I think so. I mean, NASA has shown that it is looking to partner with commercial providers all the time. I mean, with Crew Dragon and the Starliner, NASA did not pay them to build these spacecraft. NASA paid them for seats on these spacecraft. And then SpaceX owns the Crew Dragon. They build them, they can use them for tourist flights, they can use them for servicing space stations, and NASA pays to fly their astronauts to the International Space Station. And in fact, today we heard that the Russians are planning to send cosmonauts on board Crew Dragon. So you've got more customers for Crew Dragon. And so if another space station was built, and say they actually built this orbital reef and they would offer out space for people to rent and people to use, yeah, I think NASA would absolutely spend some money to be able to run some of their experiments. I think like NASA doesn't design and build their own cars, except for maybe lunar rovers. They don't design and build their own airplanes to fly. They take commercial airlines. And so I think NASA's place is to live in the spot where nobody is willing to invest money. And that's the kinds of propulsion, air technologies, space flight, things like that. But if Blue Origin is willing to build a space station and rent it out, yeah, NASA would be one of their top customers. Just like NASA is SpaceX's top customer. Ian Daniel, I don't know. You're asking about Sea Dragon. I don't know this design specifically. I know the original Sea Dragon. But like, until like people always ask like, why don't we do Sea Dragon? But Sea Dragon is not a fully reusable rocket concept. I've heard some versions that could be reusable to some extent, but I think you're going to see spacecraft like Starship, which take off. Both stages are fully reusable, can land. And in fact, Elon Musk has said many times in the past that Starship is like the minimum viable size to make a fully reusable two-stage rocket. But a much bigger version, even a Sea Dragon version, would probably work. So I don't think it needs to launch from the ocean the way Sea Dragon does. I think we can eventually, theoretically, get rockets that are as big as Sea Dragon, and they don't need to launch in the way that was originally proposed. It's a cool idea, but I think just the advantage was just to have a rocket of incomprehensible size that could launch missions in one giant launch. And the reality is that we don't have the payloads right now. Like James Webb is maybe one rocket, one mission that could have used a much bigger launcher. If a 10-meter launch fairing was available, or an 18-meter launch fairing, then James Webb would have been the right telescope. But beyond that, you've got commercial satellites. And in fact, the miniaturization is making satellites get smaller and smaller. There's actually more room at the bottom for these smaller launch providers. And when Starship, like if Starship starts flying the way they plan to, within a couple of years, they're not going to have anything to launch. Like they're going to run out of things for a while until our space infrastructure catches up with the capabilities of a vehicle like Starship. So it's going to get kind of weird in the next couple of years. We're going to fill all the backlog, and then Starships probably won't fly that often because there'll just be nothing left to launch. Oh, there you go. Nancy says that Orbital Reef actually probably will get NASA as their first tenant. So there you go. I like this question. Vanjay Brunazzo. if there was another civilization like ours in another galaxy, would our current technology be enough to detect and communicate with each other? Absolutely. If there was another civilization, even about as advanced as ours, and they had radio, the ability to send radio signals at a coherent, using like a radio dish, like the Green Bank or the Arecibo or the Chinese Fast Telescope, and you could send and receive messages across fairly vast distances if you know where somebody is and you know how you're planning to communicate with them. So up until this point, when we talk about SETI, the search for extraterrestrial intelligence, astronomers have been using their radio telescopes and they've been pointing them at individual stars and listening at various frequencies at these individual stars, hoping that there's a civilization there that is directing a message back towards us. There really aren't any methods right now where we're searching just the sky in general, trying to pick up their television broadcasts, because they fall off over time quite quickly. Like, it's almost impossible to detect a signal beyond 10 light years at our current technology. Maybe when the square kilometer array comes out, we could detect signals over 100 light years. But even that is going to be really complicated. And so you really need someone pointing their radio telescope at you, sending off a signal, and you've got to be detecting it. And so in the past, actually, astronomers have tried sending messages out using Arecibo. They picked a star system that they thought was one that could be habitable and sent a message. We didn't hear anything back, although it takes a long time. So yeah, absolutely. Theoretically, if we received some message from some civilization, we could download the whole message. We could send a response back at them using our radio telescopes and carry out a communication. The challenge, of course, is that you are separated by light years of distance, and so years of time. And so say they're 10 light years away from us, which there's maybe 100 stars within 10 light years of us. Like, maybe they're 100 light years away from us. Now we're into the, I think, 1 million stars within that distance. Or maybe 1,000 light years. Anyway, so we have to wait 100 years for a signal. So we send, hey, how are you doing? And then 100 years later, they get the message. They craft a response. Doing fine. 100 years back for us. It's 200 years for a return message. So it's interesting. I mean, it's such a great idea. And I actually don't know of a paper. If anybody does know, let me know. But I'd love to read a paper where someone has thought about, like, what is the way? Like, if we do find an alien civilization, what is the way that we communicate? How do you encapsulate all of humanity into a stream and just send it? Do you be coy about who we are, what we do? Do we wait for them to send useful information to us? It's sort of interesting, almost like game theory, thinking about what would be the way that we would communicate with an alien species on some other world in a way that tries to keep us safe, that tries to learn from them, that tries to share information, because that's all we'll be able to do. We'll essentially only be able to share knowledge with some other civilization. We learned this math. We developed these kinds of technologies. What have you learned? And then they tell us what they've learned, and then we can sort of fill in the gaps in each other's knowledge. That would be the ideal. Send each other television shows. Anyway, it'd be cool. I'd love to sort of learn more about what people have thought about this idea. Diana Galaxy. Fraser, do you know if things going into a black hole are squished or torn apart? Probably both. So as you fall towards a black hole, the force of gravity on you is different depending on how far away you are from the black hole. So you're literally, the force you feel on your feet is different from the force you feel on your head as you're getting close enough. And so eventually those forces are so different that you get torn in half. And then those pieces get torn again, and then those pieces get torn again, just because the amount of gravity is so different. They call this tidal when you essentially enter the Roche limit. Anyway, the tidal forces of the black hole will tear you apart. And they call this term spaghettification. So you sort of get torn into this long, thin stream of atoms that enters into the black hole. So that's the torn apart part. But then all of your atoms enter into the event horizon and join the black hole, whether it's a singularity or whether it's some larger object inside the event horizon, and you get mashed onto the surface of the black hole. And you are compressed, possibly infinitely. So, we don't really know what's going on inside the event horizon of a black hole. It could be that you just get added to some sphere that's maybe denser than a neutron star. And that I would call being squished, because like a teaspoon of neutron star is millions of tons. Like it's very dense. But maybe it is a true singularity. It's this point in space that is getting smaller and smaller at an accelerating rate, and your material just gets added to it. And that it's like super squished. So both. You both get torn apart and squished. Shadow Mask. Could Starship be used to dismantle and return the ISS to the ground piece by piece? I would think so, theoretically. All of the components of the International Space Station were launched by the space shuttle, by various rockets from the US and from Russia. And so they were designed to fit within either the space shuttle's main cargo bay or within the fairing size of these various rockets, whether it's a Delta or an Atlas or a Proton rocket. And the fairing size of these rockets is, say, 5 meters across, varying heights. And the fairing of the Starship is going to be, I think, 9 meters across. And so there's tons of room inside Starship to be able to gather up these components. But it would still be tricky. I mean, we don't know, like, Starship still hasn't been able to return safely from orbit. I mean, at the time that I'm recording this, we've heard that it may attempt its orbital flight sometime in November. So it could be about a month away from an orbital flight. But this is going to be empty. So it's going to fly to space, it's going to orbit around the Earth, and it's going to try and make a re-entry back through the atmosphere. But if it was gathering up chunks of the International Space Station, then these are going to be adding, in some cases, multiple tons to the weight of Starship as it's coming back through the atmosphere. And we don't know what the aerodynamics of that are going to be, whether it can still make a landing with that kind of weight on board. I'd be interested to find out. But I would say it's theoretically possible that you could do that. Or, say, grab the Hubble Space Telescope. Like, one of the original plans with the Hubble Space Telescope was that the space shuttle would go up to space, grab Hubble, load it back into the cargo bay, fly back down to Earth. Then engineers would maintain and upgrade it, and then it would be put onto another space shuttle and launched into space and continue on. And maybe do that for much, much longer. And I think that's still a great idea. It just turned out that the costs of launching on the space shuttle were so expensive that it just didn't make sense. But now the costs on Starship are going to be a fraction of the price of the space shuttle. And it might be that this whole concept of going out, grabbing satellites, bringing them back down to Earth, letting people do maintenance on them, and then launching them again is the way that makes the most sense. So I think you might be onto something. Well, there's the rain. Let's see. Hopefully Chad can remove the noise. I don't know if people can hear it. Yeah, I think we're... Yeah, hopefully Chad can remove it in the in the audio when we're doing the final one, so you guys can survive right now. All right. Oh, that's good. That's good. Samurai Hash. Fraser, on the topic of trading information with another civilization, how about sending DNA or their equivalent and creating alien life on Earth, sending our DNA, RNA to them? That is a great idea, and I'm sure it's the source of some science fiction book. I'm sure people in the comments are suggesting it right now. But I like that idea. There was a paper that came out literally today when I'm reporting, and we're probably going to report on this on Universe Today. And they're talking about the fact that humans are not going to be the ones who are going to be making interstellar trips. I mean, science fiction has told us that humans are going to get in their spaceships, they're going to fly to other star systems, but the reality is that keeping a human being alive for those kinds of lengths of time is ludicrous. But if you had other creatures that are tougher, that can handle long voyages, like tardigrades or cyanobacteria, then we could have ways of sending life to other star systems that would require vastly less resources than trying to send a human being. But as you said, the other way is that if you've got some other civilization and they've got the same raw ingredients that we have on Earth, they've got carbon and nitrogen and phosphorus and so on, then theoretically you could send them the plans to print DNA. You could send them the plans to actually construct life forms. Obviously, the more advanced technology would be required, but theoretically you could. And so we could send them ideas of life forms that we've got. They could send us life forms. But there's a million ethical problems. like even if you could do this, then you're like, are we going to be letting life forms into our environment here on Earth that are not suitable, that they would either die a horrible death under our inhospitable environment, or would run away and outcompete in their natural habitats? You know, we've got invasive species here on Earth. It's always a disaster. And so you can imagine that being an issue. I think I've read a science fiction story in the past about this, just this idea that the way you invade another civilization is you send them, say, information for an artificial intelligence or some biological life form, and you get them to build it, and then it wipes out their civilization and takes over for you. So there would be risks involved. You need to check the code very carefully as you're examining these life forms. But if it was safe, then imagine there was a place where you could go and you could say, these are the life forms that exist on this planet light years away from us. It's a neat idea. Horribly risky idea. Don't do it. Yeah, Jurassic Park. Still busy wondering if you could, but still, I like the idea. Someone should do this as a science fiction book if they haven't already. I'm sure they have already. Archon Wu. Fraser, what are the chances of the sun killing life on Earth with a solar flare or other solar weather? I would say 0. The chances are absolutely 0 that a solar flare off the sun will kill life on Earth. The sun has been around for 4.5 billion years. The Earth has been around. There have been many, many, many flares. I mean, just in our lifetimes, as we've been recording them, we've seen flares over the last, say, couple of hundred years that have been serious, like enough to cause a mega disruption on our technology, to cause auroras to be seen near the equator. Mostly it's our technology is the big risk. And so we know that the sun must have been giving off these flares throughout all of recorded time. And we don't see any evidence in the fossil record, in the geologic record, that there was a time when a deadly solar flare wiped out all life on Earth. There's sort of a range that the sun is capable of producing. And so the danger of solar flares is really an issue for us from a modern standpoint, that it's electronic equipment that is very hampered by solar flares. And we have become technologically advanced, and suddenly we have stumbled our way into a risk, which is that a big solar flare could ruin our technology and cause our lives a lot of trouble. So no, but solar flares in the past wouldn't have killed all life on Earth, because life is here on Earth, and so it won't happen in the future. Prince Charming. Can two space telescopes be used in tandem to work as an interferometer? Let's see. I'm trying to think of the right way to approach this. Sorry. All right. Here on Earth, we have interferometers. This is where you have multiple telescopes acting together as a single telescope. The best example of this is the Very Large Telescope, which is located down in Chile. And you've got 4 telescopes as well as a couple of smaller telescopes, and they can, in certain conditions, act as one big telescope. And they mainly do this when they're imaging in the infrared spectrum, because the infrared is more giving. The wavelengths are longer. And so, I mean, if we can do this in Earth, then absolutely we should be able to do this in space, where you don't have gravity, where you don't have other kinds of issues. You can essentially make your spacecraft fly in the perfect configuration to be able to do interferometry. And the cool thing about interferometry, of course, is that when you have 2 telescopes, they act like a telescope the size of the space between the 2 telescopes. But you have to get the telescopes configured so that they are down to within a few hundred nanometers apart if you're going to shoot in the visible. But there was a telescope that was proposed back sort of at the turn of the century, back in the early 2000s, called the Terrestrial Planet Finder. And the plan was to fly up to 4 telescopes in formation, which would be capable of finding Earth-sized worlds orbiting sun-like stars. And eventually they decided to cancel, NASA decided to cancel the mission, and so they never built it. But so still there has never been interferometer flying in space yet. The closest example that's being seriously considered is the European Space Agency's LISA telescope, which is actually going to be a gravitational wave observatory, but it's going to be an interferometer. You're going to have 3 spacecraft flying in a triangle formation. They're going to be holding position very, very carefully, and they're going to act as a interferometer essentially to detect these gravitational waves as they pass over top of them. And there's no reason why you couldn't do this, but it just requires flying, this formation flying, which is something that has never been tested in space to that degree. But I'm sure there are missions in the works that are hoping to be able to do that. But we've sort of gone through this point where it makes more sense to do large ground-based observatories. Like for the longest time, it was space telescopes is what you needed, because you needed to get above the atmosphere of the Earth. But then with the development of adaptive optics and interferometry, you can suddenly build ground-based telescopes that are as if they're flying in space. And on the ground, it's a lot easier to build a much bigger telescope than build something that you would fly in space. And so that's why we're seeing this new round of giant telescopes, the Giant Magellan Telescope, the 30-meter telescope, the extremely large telescope. All of these are 30-meter plus class telescopes. And they're with adaptive optic systems on board. And they're going to be capable of imaging Earth-sized worlds orbiting sun-like stars. So it's sort of the need for an interferometer just hasn't come up yet. But I'm sure there's some in the works, and eventually we will see them fly. All right. Man, this is a storm. Fulmer Duckworth, what do you think about UAPs? I think that I am not convinced that they are advanced vehicles. I think that they are, I've seen some I've even interviewed Mick West. I think they're entirely explainable through their balloons, their aircraft seen with an infrared sensor, their birds. They are out of focus lights seen with a night vision glasses. I mean, each one has been explained so far to my degree of comfort that even if that explanation is kind of wrong, it's still like it doesn't require some super advanced alien aircraft or even some advanced society on Earth. So far, I'm unconvinced by that UAPs are anything other than just unexplained but natural things. Ricardo Ferreira, how does the ISS deal with static electricity? I don't actually know. I don't know how they do that. That's a great question. I apologize. Let me see. Let me just see if it is an issue. I know that hold on a second here. Okay. So I'm going to study this for the future. But so the International Space Station, so there is an issue with static electricity. It can actually be pretty deadly. And so the station has a device on board called a plasma contactor unit that the astronauts use when they are at risk of arcing to the space station. And so they will ground themselves to the polarity of the space station and then go out. So there you go. Very cool. David, that was my answer. David Sims. Kilonova and supernova. Okay. UK Man Loves Goddesses. How big is the extremely large telescope? 39 meters. Where are we at? 550. Okay. Sebastian Garepi, is SpaceX exchange with Roscosmos a seat training for Yusaku Miyazawa for seats on Dragon? I don't know that part of it. All I know is that about a month ago, SpaceX or Elon Musk was invited to talk with the Russian leader of Roscosmos, and for the longest time they've been sort of publicly fighting, and suddenly they had a turnaround, and now Russia is fine sending cosmonauts on board SpaceX capsules, which is good. Sort of more mixing of ways of getting up to the International Space Station. So it would be, will there come a day when the Russians can no longer launch Soyuz? That would be pretty frustrating for them, I think. But I don't know about what you're talking about Yusaku Miyazawa. Physics Police, have I read Andy Weir's latest book? I haven't, but my wife just did. So she wants me to read it now so that we can then talk about it, because she says there's a bunch of ideas in it that she really liked. So I haven't yet, but I will. Her review was, overly, it's Andy Weir's style. So very humorous, almost too humorous, but also some really great ideas. So Miguel Angel Romero, Fraser, the lost frames today normal for your Starlink or the rain effects, your service in the Canadian woods? Yeah, it's normal. People have been watching this. I would say the Starlink drops frames. Let me see how many frames I've dropped. I've dropped 1.92% of my frames. I've dropped about 1,200 frames. And I can see the speed kind of going up and down. So far, bad weather hasn't been a problem, but when we had a hailstorm and the top of the dish was covered in hail, it was unusable. I had to go out and scoop off the top of the dish to get all the hail off of it. And so I'm assuming when it snows, it's going to be the same issue. I'm going to be out there all the time trying to wipe the snow off of it. Apparently, it runs hot, and so it should melt the snow off of it. But if I want the internet to work right away, and I always do, then I'll be out clearing it off. Let's see. One more time. Just a bunch of ones here. Walid Damuni, I've heard about the idea of the diagram of the Lofstrom launch loop, but it's too big to build. What about a vertical railgun in a skyscraper 11 kilometers tall? It seems a lot easier to build and very reusable. I at this point, I mean, all these other ideas, space elevators and launch loops and all this kind of stuff, like a fully reusable 2-stage rocket like Starship has a ton of flexibility. The costs are going to be really low, that I don't think any of these megastructure launch facilities are just going to make sense. They're not going to be cost effective compared to this. And as I said earlier, if Starship is the smallest possible version, imagine one that is 4 times more massive, 10 times more massive, and the economies of scale as these rockets get bigger and bigger. So I don't think any of these things make sense. I mean, it's really hard to gather together the funds to build something. An 11-meter tall skyscraper railgun, like, that'll be trillions of dollars. While Starship's just going to be there at $1 million a launch, just flying 150 tons to space. So I've mentioned this in the past. I think we're going to run out of things to launch to space, especially as we get our orbital manufacturing happening. Why send things to space from Earth when you've already got stuff out in space? Gravity wells are for suckers. So I don't think any of them make sense. They're all like science fiction ideas. Physics Police, I'm excited for China to build their mega space station. Yeah, their kilometers long space station, which would be like 10 times bigger or 5 times bigger than the International Space Station. I mean, at some point I can imagine space stations that big, but it still feels like it's a long way away. And I'm not really sure what the practical need of those mega projects are. Like, space sucks. So there's not a lot of really good reasons to send human beings to space. Like the need for human beings in space is about 10. Like, on a space station, like the International Space Station, doing all of the science that's possible. Everything else beyond that is just going to be tourism. There's no economic reason to live in space yet. Now, maybe in the future, our technology will trivialize living in space and we'll be living in these O'Neill cylinders because that is the most effective, efficient way for human beings to live, is out in space. But it's a long way off. And it's the same reason why the population of Antarctica hasn't grown, right? You've got a few hundred people at most living in a horrible environment, just trying to stay alive to do the science that's required in Antarctica. I just can't imagine a time when, in the near future, that we need to have lots of people living off Earth at all. And I know that's not what you want to hear from me. You want to hear about the bold space exploration, the vision of living on Mars and living on the moon, but there just is not a lot of need for human beings to do these things today. I think we need to explore. I think we need to have a base on the moon where we explore the moon. We need to have a base on Mars. We need a base on asteroids. Let's send people to Titan. But it's all about exploration, not about living. Whoa. Windy. Got a bit of a storm going on. All right, I'm going to wrap up now, but I'll stick around for some extra time. Okay. More questions in a second, but first I'd like to thank our patrons: Greg Amelia, Paul Kaup, Bill Hamilton, Jorn Albert, Truck Captain Stumpy, and the rest of our 802 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. The outro. All right, thank you everyone for joining me and asking me all of these incredible questions. I really enjoy it. Thanks to everyone who posted your questions in the comments. I get a bunch of them and answer them in the show, but also all the people who join me for the live show. Again, we do this every Monday at 5 p.m. Pacific time. And so you can join and ask your questions live and even have a back and forth conversation with me and other people watching. So come join us sometime. All right, we'll see you next week. And I'll do the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right. I'll stop the recordings. And that one. Okay. Okay, awesome. All right. Why does the fun end? I don't understand how people can, like, do live streaming on Twitch for like 6 hours, 8 hours on a time. Like, it would just destroy me. I can't do it. Anyway, all right, let's see. Kernow Zach, did Chandra just find the first exoplanet ever discovered outside of the galaxy, or is it probably just gas and dust? It's probably legit. It's just that the technique they use, they essentially were looking at the X-ray flash of a planet passing in front of a star, and they were able to detect, they use gravitational lensing in the way they find planets here in the solar system, but they were, here in the Milky Way, but they were able to find a planet in the Whirlpool galaxy, which is kind of incredible. And I think it was like a star passed in front. I haven't gone deeply. It's like a star passed in front of an X-ray object and changed the light of it, and as it was passing, it also got the distortion of the planet that was orbiting around the star. And it's all so precise, they were able to theorize that there was a planet orbiting that star in that other galaxy, which is not surprising. Like, you expect there would be there, but it's still impressive that they did it. And they'll never be able to see it again. RJQ, do you think one of the reasons Trident wasn't selected because the proposed launch window in 4 years would require a quick turnaround? No, I don't think so. I think, I wasn't there for the selection process, but it's just that Venus is really an underexplored planet, and so the pressure was building in the scientific community to explore Venus, and you've got like a lot of really interesting discoveries. Like, the last time they mapped the surface of Venus was in 1988 with the Magellan spacecraft. And the resolution is terrible. And so, like, I think it's like 30-meter resolution from the Magellan. And so they're going to send a proper high-resolution scanner to Venus to do a new survey. So I think it's just a lower priority. I mean, obviously a mission to Triton would be amazing, but let's see. Get some of the newer ones here. What was the name of the book? What was the name of the new Andy Weir book? I forget what it's called. Someone will mention in the chat. Bomdia, do you foresee James Webb to have huge noticeable differences in images compared to Hubble? Oh, yeah. Yeah. The example that I always love to give is that Hubble is able to see galaxies that are, say, just a few 100 million years after the Big Bang. But they can only do that using gravitational lensing. So they look at some giant galaxy cluster, and they're able to see the distorted image of another galaxy which is behind it. And it's only when you have those really perfect situations that line up can you observe the most distant parts of the universe. James Webb will be able to do that just raw power. Anywhere it wants to look, it'll see galaxies forming shortly after the beginning of the universe. So the capability of James Webb, I mean, it is 7 Hubbles all together. It's going to be incredible. And we are 2 months away now? Yeah. The Delicious Plum, how are your skies? Any wonderful clear nights for viewing the cosmos? No. So we've been living here for about 2 months now, like full time. And I've had maybe 3 nice clear nights so far because we have just clouds and rain here on the West Coast from September on. So I was able to see the recent auroras, which was pretty cool. And I've had a few clear nights that have gone out, but I'm waiting for summer. So I won't be able to really get back to you on how good the skies are here until May. But then hopefully we'll have the new studio. Probably going to set up an observatory as well. So I'll probably be able to do some live streams with the telescope. Yeah. So the virtual star parties will be back on, but like from my backyard. Ricardo Fiera, when do you think we'll build a radio telescope on the far side of the moon? Pretty soon. There's a lot of energy building for far side lunar radio telescope. It's some pretty clever ideas to deploy it. So I wouldn't be surprised if we see one announced within the next couple of years, and maybe by the end of the 2020s, something that's actually operational. Nathan Conklin, what's your cosmological theory? Do we live in a multiverse inside of a black hole or an expanding universe that is expanding faster and faster at the edges? I'm a journalist, not a cosmologist. So I don't have an opinion about any of these things, about anything really. My job, obviously I have lots of opinions, but when it comes to stuff that's beyond my pay grade, like mysterious controversies that astronomers argue over, like what is dark matter, I don't have an opinion because I don't have enough info. I don't know enough. So all I can do is listen to what the experts say and try to report them as best I can. Try to synthesize what other people are saying, who are actually making the discoveries, in a way that is not wrong. That's my job. So do we live in a multiverse? I don't know. Do we live in a, what is the, I think, so if what is the consensus of astronomers, right? That's in general the kinds of things that I will respond to, but I don't have any opinions about that kind of thing. Just a journalist. My background is in computer science. There you go. Project Hail Mary, says John Seffield. So there you go. Observatory on the roof. No, I'm going to probably build a separate, just roll off like a shed with a telescope inside of it. And then I can just extract the shed and have the observatory. That's the plan. So it'll be a telescope in a shed that'll be on rails that I can drag away and then I can have access to the sky is the plan. Okay, let's do a couple more here. So many good questions. Scrambles. What part of the world can you see the edge of the Milky Way from? We see the same part of the Milky Way from everywhere on Earth. Like the Milky Way is a structure in the sky. Like imagine, like we're in the Milky Way. And so if you imagine, the Earth is a sphere and it's turning in space. And from our perspective, what we see is space turning around us. But obviously we're the ones that are doing the turning. And so during the summertime for the northern hemisphere, the sun is located in the winter constellations. And so we can see the core of the Milky Way during the evening in the summertime. And then during the wintertime, now the sun is located in the center of the Milky Way. And so we're able to look out to the outer regions of the Milky Way. But really, on any night with good dark skies, you can see some portion of the Milky Way, whether you're looking coreward or rimward or upspin or downspin. But we would have to be outside of the Milky Way to be able to see the edge of the Milky Way, because we're stuck inside of it. It's like, where can you stand in your house to see the outside of your house? There's no place you can stand in your house to see the outside of the house. Lord of Entropy, how safe would spaceflight need to be before you get on a flight? Air travel safe? Car travel safe? Air travel safe. Yeah, cars are not safe. But I would go with like a little less safe than air travel. I think I would say like the Blue Origin, like New Shepard is starting to look like it's pretty safe. I'm not sure about the Virgin. Like Virgin Galactic's already had one accident that's killed a person. So, but the New Shepard seems like it's safer, and looks like Crew Dragon is pretty safe. I would probably take a flight on Crew Dragon if it was offered to me. Maybe I'll wait a little longer. I'm pretty hesitant to risk my life right now. So Scrambles, I meant the outward view to the rim. Yeah, so just like in the wintertime, just look up and you'll see the Milky Way. It's a lot dimmer than it is in the summertime, but you're still seeing but you're seeing outward through the Milky Way. So just wintertime in the northern hemisphere. Let's see. Nifty, I propose a rover race around the moon in one moon day. Good old competition for its own sake. Is this feasible? Huh. So you would have to go, you'd have 28 days to go. Let's see, what is the circumference of the moon? It's 11,000 kilometers. So 11,000 kilometers divided by 28 days is 392 kilometers a day. So, I mean, if you were driving a car, you could do it. It'd be pretty tricky to drive a lunar rover around the moon on one lunar day. But if you could, I mean, it's a cool idea, because if you went the speed of the lunar day, then you would be able to stay in sunlight the entire time. And the second you fell beyond the terminator, then you would run out of power and your car would freeze up. So again, I can imagine a science fiction story where you've got a team of lunar rover race car drivers who are attempting to race around the moon, and they know that if at any point, they're all solar powered, and they know if at any point they fall below the terminator, they could have all kinds of issues show up that stops them from being able to drive, and they'll freeze to death and run out of power if they do. I love it. That's awesome. It's a clever idea. Do it. Edward Teach, will there be another mission to Pluto? Eventually, sure. There's no mission has been officially announced yet, but I've talked to Alan Stern quite a few times about this, and he definitely has his hopes, a lot of mission concepts in the works to be able to go back to Pluto. And I think the next thing would be some kind of like orbiter, and ideally a lander. So you'd want to have some orbiter at Pluto, and then you'd want a lander. And so that would be the next level. That's sort of the way these missions go, is you start off with a flyby, and then you do an orbiter, and then you do a lander, and then you do a rover, and then maybe you do a sample return. So we're just at the very beginning of that. Oh yeah, no chance of saying in the South Pole, days last 14 days on the moon. Yeah, I mean, as you get closer to, that would be at the equator, but if you got closer and closer to the South Pole of the moon, then you don't have to go as far, or the North Pole. And so maybe you actually could have a rover that's, man, this is such a good idea. Like, I think you'd have a rover, you'd have some track, and your rover would move at the speed of the day, and it would stay in sunlight the entire time. And so if you got closer and closer to the pole, then you must be able to get to a point where there's like a track you could take that you only have to go 50 kilometers or 100 kilometers over the course of a lunar month and stay in sunlight the entire time. That's a really good idea. That's so good. All right. Got that, NASA? You listening? As long as you can keep your rover going, you can stay for an entire, just be in full sunlight operation all the time. All right. And so Nightbot is recommending, we've got the weekly Space Hangout on October 27th, so tomorrow. And our guest is Dr. Stephen Alexander, cosmologist. And then on Friday, we've got the next episode of Astronomy Cast, and we're going to be doing ice giants. So there's the upcoming shows. All right, I'm going to wrap things up now. Thank you, everyone, for joining. Thanks, as always, to all the moderators, and special thanks to Nancy Graziano and Chad, if he's still sticking around. I've got an interview with, I mentioned this, and now I've got the official time. I'll give you a couple of interviews that are coming up. I'll post them shortly. Come on, Google. Okay, so Friday morning at 8 a.m. my time is Justin Simon from NASA, and he's on the Mars Perseverance sample collection team. So we will be talking about sample collection for Perseverance, as well as like sample return missions and so on. And then next week at the same time, at 9 a.m., so November 5th, I've got Dr. Boris Goncharov, who is pulsar timing arrays. We're going to talk about the search for primordial gravitational waves, the search for merging supermassive black holes. And that's next week. All right. Thanks, everyone. And we'll see you all next week.